Hello, today we are going to talk about the body does to drugs after you take them. Drugs have to get to the brain. That's the only way they can make somebody feel different, and it's the only way to get high. For drugs to get into the brain, they have to be in the blood, and the various factors determine how much drug get into the blood in the brain, and how long then remain there. Overall, what happens to drugs in the body is referred to the drug's dynamics. The first thing that happens after you take a drugs orally is that it has to be absorbed from the stomach and the intestines into the blood. From the blood it passes into the brain, and again all these drugs have to get into the brain to have an effect. A large fraction of the blood pumped from the health problem directly to the brain, and drugs that injected directly into the bloodstream are not absorbed by the stomach, but are still passed into the brain. Some drugs, such as nicotine or inhalants, are absorbed directly from the air in the lungs to the blood. Different drugs have different absorption efficiencies. Some drugs are nearly on absorbs and others are not. The next step is the drug, the metabolism or changed. The metabolism or chemical modification of the drugs can result in the cessation of their action. The metabolism can also change the next step, which is excretion. Drugs metabolism usually takes place in the liver, but it can take place in the other medullary organs as well, in the enzymes in the liver, and also where that modify or structures of drugs. An example is the metabolism of ethanol, which is them changing further into acetate. Acetate is not an active substance, so metabolite or ethanol is inactive, and the effect of taking ethanol or alcohol is determined by its metabolism. This next example shows the many possible metabolisms of nicotine. You can see that it's extraordinarily complicated, and very different kinds of metabolites and chemical structures are possible. Of course, you don't have to remember all of this. I show you this just to give you an appreciation of how complicated drug metabolism can be. The next and final step in drugs generally in the body is drugs elimination. Drugs and their metabolites are elimination includes clearance, which is a measure of the body's efficiency in eliminating a drug. And the second of elimination, half-life. Half-life of a drug is a measure of the rate of removal of the drug. Is the time needed to remove or metabolize 50% or half to the drug. So we have discussed three main steps: drug absorption, drug metabolism, and drug elimination. This graph deals with the idea of half-life. It shows the disappearance to two different substances, A and B, from the blood, and they have different half-lives. Drug A has a shorter half-life, and drug B has a half-life twice that of A. When we look at the levels of these drugs in the blood, which are the solid lines, you can see that one of the colors has to zero much faster than the other, and that means the drugs A have a shorter half-life. If the half-life is shorter, then the drugs disappears faster. Normally, for 97% of drug to be eliminated from the body, it will take 5 half-lives. But if a drug is taken orally, then the drugs have to be absorbed first. So it's actually in the blood, which are the dotted lines in the image. After it builds up its peak, it's that eliminated at the rate according to its half-life. It's worthwhile pointing out that not all drugs are metabolized in the fashion. Phenol, for example, is metabolism at a steady rate rather than at fraction rate. Now I would introduce the topic for next time. On the practical impacts of a drug being expected into the urine is that many drug screens and tests have been developed to screen from the presence of the drug in the urine.